The National Electrical Code, or NEC, does not define a specific amperage level considered objectionable for grounding conductors. Instead, it offers guidelines for assessing whether a grounding conductor carries objectionable currents. Article 250.6 of the NEC dictates that grounding conductors should not carry load current or objectionable ground currents. Objectionable ground currents can lead to overheating or create dangerous voltage on the grounding conductor or other connected conductive materials. To determine if a grounding conductor is carrying objectionable currents, several factors need evaluation. Firstly, the magnitude of the current flowing in the grounding conductor is a critical consideration. Higher current levels are more likely to be objectionable. Secondly, the duration of the current flow plays a role. Sustained current flow poses a greater risk compared to brief surges. Thirdly, the impedance of the grounding conductor is important. Higher impedance can lead to greater voltage drops and heat generation. Fourthly, the temperature of the grounding conductor should be monitored. Overheating indicates potentially objectionable current flow. Fifthly, the presence of other conductive materials connected to the grounding conductor needs to be assessed. These connections can create pathways for objectionable currents. If any of these factors suggest that the grounding conductor is carrying objectionable currents, corrective actions are necessary to reduce the current flow. One possible solution involves increasing the size of the grounding conductor. A larger conductor offers lower impedance, reducing voltage drop and heat. Another option involves installing a separate grounding conductor. This provides an alternative path for fault currents, reducing the burden on the original grounding conductor. Other strategies can further reduce the magnitude or duration of the current flow. In addition to these general factors, the NEC provides specific examples of situations where objectionable ground currents may occur. Firstly, when a grounding conductor connects to a neutral conductor, objectionable currents can arise due to imbalances in the neutral circuit. Secondly, when a grounding conductor carries fault currents, it's essential to ensure it's properly sized and protected to prevent overheating. Thirdly, when a grounding conductor connects to a conductive surface exposed to moisture, corrosion and increased impedance can lead to objectionable currents. If any of these situations exist, taking steps to reduce current flow in the grounding conductor is crucial. Failure to address objectionable ground currents can result in fire or other hazards. Mitigation strategies should be implemented to ensure a safe electrical system. Always consult the NEC and qualified electrical professionals for guidance on identifying and addressing objectionable ground currents.